In this video, we're going to discuss CRA models for dividing a whole number by a decimal. So we have two examples we're going to look at, one with a whole number quotient, one with a decimal quotient. So our first one is going to be 2 divided by 5/10, and we're going to show why that's equal to 4. So when we have a decimal as our divisor, it's going to be easier to think of this and model this as a measurement division problem. Okay, so this is going to represent the size of each group then, this 5/10. So from this quantity of 2, right, so each of these represents 1, we want to divide this quantity into groups with a size of 5/10 and show how we have 4 groups then. Okay. So since we just have these 2, we can't create groups with 5/10 with these solid objects. So I'm going to exchange these or regroup these into 10/10. Okay, so 10/10, right, it's the same quantity as 1, but this will just allow us to break the model up. Okay, so we still have the 2, and then again, I'll just kind of spread these groups out since I don't have a lot of room here. So there's a group of 5/10, here's a group of 5/10, here's a group of 5/10, and there's a group of 5/10. Okay. So every piece in that original quantity of 2 has been divided into groups with a size of 5/10, so we don't have anything left to do. And then again, if our divisor is representing the size of each group, our quotient will represent the number of groups with that size of 5/10. So we're looking at how many groups with the size of 5/10 do we have? We have 4. Okay. So that's our first example where we have a whole number quotient, and then we'll look at, I guess I'll show the representational model real quick too. I just printed a grid off for this one since it's a little more tedious to draw all of these, and I've already pre-colored these, so I have 5/10 shaded purple, 5/10 shaded red, 5/10 shaded blue, and then 5/10 shaded green. Okay, so some sort of drawing where we're just kind of shading these with the representational model, and then this will be the abstract model, is that equation. Okay. All right, so now we'll look at the example where we have a decimal in our quotient. Okay. So we're going to start with 2 again. So that's our dividend or starting amount. We're going to divide this into groups with the size of 8/10 this time. Okay. And then we're going to show why this is 2.5 groups, or 2 5/10 of a group that have a size of 8/10. Okay. So again, my first thing I need to do, I can't separate this into groups with 10 since it's a solid piece, but each of these represent 1, so I'll exchange these or regroup these as 10/10. All right, so same size, so we're not changing the total value or total quantity here. We're just exchanging the size of the parts. Okay, so we have another 10 there. Okay, and then I want to create groups that have a size of 8/10. Okay. So I'm just want to leave a little gap here. Okay. So to create the groups of 8/10, right, if I just move 2 of these away, so I'm just going to kind of keep stacking on this way. So here I have 8/10, right? Each of these strips is a 10th, and I have 8 rows of that. Okay, so that's one group that has a size of 8/10. So I'll create another group that has a size of 8/10. Okay, so I have 2 total groups with the size of 8/10, so that's where that whole number comes from. And here we have 4/10 left over. So we'll need to rearrange these pieces, kind of decompose these and break these apart a little bit to more clearly show why this is 5/10 of 8/10. Okay. So what we're going to do is essentially we're going to break these all into hundredths. Okay. Because each of these columns of 8, right, this has a height of 8/10, and then right now they have a width of 1. Right, so that's why we have 8 full tenths that are shown, right? So this 1, right, is that full length of 1, and then we have a height of 8/10. So when we want to show that we have, right, we need to think of this in terms of groups with a size of 8/10, so we basically need to have those columns with a size of 8. So that's why we're going to have to decompose this into all the hundredths here. Okay, so we have 40, right? We have a total of 40 hundredths that we'll need because we have four tenths here. And again, I'm going to use all of our hundredths and create these stacks of 8. Okay. So there's a total of 8 there. Now I have 16. Again, I needed the total of 40 since I had 4 tenths. There's 24. 32. And then 40. Okay, let me just push these into... Okay. So again, this group has 8 tenths because it has 8 full tenths. So another way we can kind of, if we're just focusing on one of these models here, just one this kind of middle portion. Right, this has a height of 8 tenths and a width of 1. Right, so 1 full tenth there. So we have 8 tenths shown. Okay. So if we're thinking of this kind of from that perspective of the area model, right? If we compare this to this portion on the right, this still has a height of 8, but it doesn't have a full tenth, right? Of each tenth here, we have 5 tenths of this tenth, right? So if we break this tenth into 5 equal parts, each of these is a tenth of a tenth, right? So we have, since we're cutting out this last half of this model here, I kind of view it this way, right? So then this portion here is representing 5 tenths of a group that has a size of 8 tenths. So that's where that 5 in that decimal point comes from. So the 5 tenths of a group with a size of 8 tenths. Okay. So this is kind of the tricky step in the model because some will get to, right, we have these 4 tenths left over, so they might want to write a 4 in the tenths place. Right. But again, this is 4 tenths of one whole. We're trying to say how many groups with a size of 8 tenths do we have. So we have to kind of match this format of groups that have a size of 8 tenths. So we'll have that height of 8 tenths here. And we're looking to see how many tenths of a group with this size do we have. So we have 5 tenths of that group. Okay. So that's a concrete model. We can do kind of a similar thing with our representational model. And so we had that total of 2 started, so I had the 8 tenths shaded here, 8 tenths shaded here, and then again, so those are my 2 full groups, the blue and the red. And then over here, right, I have 4 tenths of a whole that are shaded. But again, we want to figure out how many groups with the size of 8 tenths do we have. Okay, so that's why we might want to, or we can use a separate grid to reorganize these to figure out, okay, if this has a height of 8 tenths, how much of a group of 8 tenths do I have? Instead of having full strips, I have 5 tenths of that strip. So this portion represents 5 tenths of a group with a size of 8 tenths. And then our abstract model will obviously be our equation at the top of the board there.